Okay, so we talked about using law of sines, but we want to make a note of when we can't use law of sines, we have to use this thing called law of cosines, okay? So we use the law of cosines when we are given side, angle, side, or side, side, side triangles, all right? Now, there are formulas, and they are all the same thing. We just manipulate it based on the letters. So I'm just going to write these real quick, and then you guys can copy them. So the other one is b squared equals a squared plus c squared minus 2ac cosine of b. C squared equals a squared, whoops, sorry about that, a squared plus b squared minus 2ab times cosine of capital C. All right, and the alternative form is if you're looking for an angle, then use b squared plus c squared minus a squared all over 2bc. Cosine of capital B is a squared plus c squared minus b squared all over 2ac. Cosine of C equals a squared plus b squared minus c squared all over 2ab. All right, so let's try some examples. So number 1. All right, so we have a side that we are looking for. So we use the standard form equation. So what I recommend doing is going ahead and starting labeling your triangle. Now, if this is capital A, then the side across from it is little a. This is capital B for the angle. The angle is capital B. The side across from it is little b. And if this is capital C, the side across from it is little c. So what we're going to do here is we're going to do b squared equals, all right, and then we use our a and our c. So we have 28 squared plus 16 squared minus 2 times 28 times 16 times cosine of 127. So all I'm doing is plugging in a, b, and cosine of capital C. So that ends up with b squared equals 1,579.2. So that's a point. And then if we take the square root of both sides, b would equal 39.7 inches. Okay? Let's try number 2. So again, I'm going to label this A, B, C. So across from A would be little a, across from capital B would be little b, and across from big C would be little c. So if we're looking for A, we're going to plug in a squared equals, then we have b squared. So we have 25 squared plus 12 squared minus 2 times b, which is 25, times c, which is 12, cosine of capital A, which is 36. So then we just type all of this in the calculator, and that should give us 283.6. So then you're left with A equals 16.8 miles. All right, you guys try number 3. All right, so number 3, the answer should be, let's see, you would have had to draw this yourself. So you have A, B, C, A, little c, and little b. And the answer you should have gotten was that C was 24.5 feet. And don't forget, AB is the same thing as C, okay? All right, so what if you're looking for an angle? Okay, so if you're looking for angle, you have to use the alternative form, so the ones that have cosine of an angle. All right, so again, I'm going to label this A, B, C. This will be A, this will be little c, and this will be B, okay? So we're looking for cosine of capital C. So we use a squared plus b squared minus c squared all over 2 times a times b. Type this all in the calculator and you get that cosine of capital C is 0.6643. If you do the inverse cosine of each side, so inverse cosine of each side, you should get that C equals 48.4 degrees. All right, now you guys try numbers 5 and 7. So if you tried 5 and 7, then you should have gotten that x x equals 30 degrees. And down here, you would have had that x was 137 degrees. Okay? All right, so then an application problem. So you have a helicopter, and he has 2 landing pads. Okay? So the helicopter's up here. Pad A is here, pad B is here. It is 14 miles to pad A, and it is 8 miles to pad B. Okay? The landing pads are 20 miles apart. Find the angle of depression between helicopter and landing pad. So we're looking for x here. All right, so we do cosine of our angle equals the angles that are, the side lengths that are next to it. So 8 squared plus 20 squared minus the angle that's across from it, which is 14 squared, over 2 times the 2 sides that are next to it, 8 and 20. So if you plug all of that in the calculator, you get that cosine of x equals 0.8375. And x, if you do the inverse cosine of each side, would give you 33.1 degrees.